Hello students, today I am back again with the explanation of few more topics from the chapter Electricity. So let's begin. In my last video, we have learned about current, and today we are going to learn about a device which is used to measure current. The name of the device is Emitter. This is the picture of Emitter. This is the circuit diagram which shows how emitter has to be connected in a circuit. You see, here it is written always place in series with the device. That means emitter always had to be placed in series in a circuit. We'll definitely know about series and parallel circuits along the discussion. And never place it across the device means that emitter should not be placed in a parallel circuit. Unit. We have already learned that the unit of current is ampere. So the measurement that we are going to get from an emitter is in ampere or milliampere. Milliampere means 10 to the power minus 3 ampere. It is a smaller unit of current. Now, let us move on to our next topic, that is electric potential. We know that potential means the ability or the intent to do work. Electric potential is defined as the amount of work done in bringing a unit positive charge from infinity to a given point in the electric field. Here, the amount of work done in bringing a unit positive charge means that we have to take a unit positive charge means one positive charge which is at infinity. Here infinity means a very far off distance. We have to bring this charge from here to any given point in an electric field. So bringing about anything from here to here requires work. So this amount of work is known as electric potential. This work done is a scalar quantity and its unit is joules per coulomb or volt. Volt is denoted by capital V. Now let us move on to potential difference. We have already learned what is electric potential. The definition is here. We have also learned it is a scalar quantity and its unit as well. Now what we are going to learn is potential difference. The difference of potential between 2 points. In order to understand potential difference, we need to understand this diagram. Let us consider this point as a unit positive charge which is at infinity. So I have brought this charge from this point at infinity to A. So I got electric potential at point A. Again, I will calculate the energy required or the work done in moving this point from here to B. I will get the electric potential at point B. Then I will subtract them. Then I will find the potential difference between point A and point B. Similarly, as water does not flow if there is no difference in level of water in both the places, similarly, electricity does not flow if there is no potential difference. So we can say potential difference is responsible for the flow of current in a conductor. This potential difference can be measured with the help of voltmeter. Voltmeter is a device which calculates the potential difference between 2 points. Now we are going to learn about how to calculate potential difference. Potential difference equal to work done divided by quantity of charges moved. That means we have seen in the definition that potential difference is the amount of work done in moving a unit positive charge. In order to find the work done of unit positive charge, we need to divide the total work done by the total number of charges moved. Here potential difference is denoted by capital V, work is denoted by capital W, and quantity of charges moved is denoted by Q. SI unit of potential difference is volt. We know that the SI unit of work done is joule and that of charges moved will be Q, coulomb. So volt equal to joule by coulomb. This is the picture of a voltmeter. We have already learned that voltmeter is an instrument used to measure electric potential difference between 2 points in an electric circuit. And this is a circuit diagram which shows how voltmeter is connected in a circuit. Now, let us go back to the diagram of emitter. Here you can see emitter is connected in a single straight line in the circuit. Here, no joints or any line has come out from any points where two lines or two wires are connected. This whole thing is a single straight line. This type of connection or circuit is known as a series circuit. But here you can see a joint. This is a single straight line and these two are joints. So we can see a junction where a different wire is connected in this circuit. Here a different wire is connected to the voltmeter, and this type of circuit is known as parallel circuit. Circuit where no joints are found are called series circuit, and circuits where joints are found are called parallel circuit. So voltmeter is an instrument for measuring electrical potential difference, and it had always had to be connected in parallel with the resistance. Now let's move on to our next topic, that is Ohm's law. Ohm's law was stated by George Simon Ohm, and it states that if physical conditions like temperature are kept constant, then the amount of current flowing through a conductor is directly proportional to the potential difference across its ends. In simple terms, it means that current is dependent on potential difference. If the potential difference increases, current will flow more and vice versa. Here we can see I directly proportional to V. In order to remove this proportionality sign, we have to take R as a constant. R is a proportionality constant called resistance. We'll go to the definition of resistance and what it is actually later on. Before that, we should understand how to draw a VI graph. While drawing a VI graph, we have to see that current always remains in the x-axis and potential difference remains on the y-axis. And this straight line indicates the VI graph. These black dots are the points that are taken. That means from here we can calculate the change in potential difference along with current. We have just learned from Ohm's law that V equal to IR. That same equation can also be written as I equal to V by R. From this equation, we can say that current is directly proportional to the potential difference. That is the Ohm's law. That means if V increases, I will increase. From this same equation, we can also say that if R increases, then I will decrease. That means current is inversely proportional to resistance. Now the question is, what is resistance? Resistance is an electrical quantity that measures how the device or material reduces the electrical current flow through it. In simple terms, it provides hindrance or obstacle to the flow of current. Let us go to these two diagrams. This shows a straight pipe through which water is flowing. It provides less resistance, but if it becomes narrow, then it will provide more resistance to the flow of water. From here, we can get the idea of resistance. That means this is a free flowing line which provides less resistance, and this is a narrower line which provides more resistance. The SI unit of electrical resistance is ohm. Now let us move on to factors affecting resistance. In the first thing here it is written that R directly proportional to L. Now what is L? In order to know about L and A, we have to refer to this diagram. L is the length of the wire. So according to this, if the length of the wire increases, then the resistance will also increase. Second one tells us that R proportional to 1 by A, or R inversely proportional to A. That means if this cross-sectional area increases, then resistance will decrease. By combining 1 and 2, we get R proportional to L by A. Again, in order to remove this proportionality sign, we have to take a constant. This one is known as rho, or resistivity. Resistivity is a constant term. It varies from material to material. Rho is a constant known as resistivity of the material. This value or constant varies from material to material. Now how to find the value of rho or resistivity? From the earlier equation, we can find out rho as R into A by L. If I take the value of L to be 1 meter and A to be 1 meter square or 1 square meter, we will get rho equal to R. So this resistivity of a substance is numerically equal to the resistance of a rod of that substance, which is 1 meter long and 1 square meter in cross section. This is how we can find the value of rho. We know the unit of resistance is ohm, unit of cross sectional area A is meter square, and that of L is meter. By putting on all the units here, we get the unit of rho to be ohm meter. So we can say the SI unit of resistivity is ohm meter. The symbol of ohm is this one, and we write meter as M. So we write ohm meter as the unit of resistivity. So this is the end of today's explanation. I hope all of you have understood the explained topics. Next week, I'll be back again with the explanation of few more topics from the chapter Electricity. Until then, take care, stay safe, and study hard.